Thank you so much. So yesterday I gave a talk and I talked a lot about some of the creative work that I've been doing with AI, specifically around using image generation systems and large language models within a theatrical performance. And tonight I'm going to talk about some research that I've been working on at Stanford that is a little less of a creative tool and more of an analytical tool, but this work is very, very new, very still being built, and with all of the talks that I like to give, I kind of love to open up a space for conversation. So if there's things that you think are interesting or inspiring or things that you're like, oh, hey, Michael, have you thought about this? So please, 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 when we get to the Q&A, I would love to hear that because you'll see me, I'm looking in the dark with many of these kinds of works, and this work in particular, because we're still developing it. So I'm going to talk a little bit about this project that I've been working on with these guys. The three people who aren't me are the developers who work at the Center for Interdisciplinary Digital Research at Stanford University. So they are a team of software engineers that work with faculty members and help them kind of understand or build systems that faculty members can then use to kind of understand a little bit more about what they're doing. And so I kind of approached them and asked for help with a pose detection system that I had been working with. I got really inspired when I was at another talk at Stanford about a team that was working on self-driving car vision systems. So using cameras on cars to detect people and passengers and objects in the way of a car so that the car doesn't crush people or drive into buildings or any of the things that can happen. And I was interested in how specifically those algorithms were able to pick out the precise poses of people's bodies. And the developers were talking about oh, it's so difficult when someone is hunched over to detect the difference between which way are they going and will they enter the path of the car, that kind of thing. And I kept thinking, I think there's a theatrical application for these algorithms too. And so I really kind of became obsessed with this idea. And what I'm going to go through today is just kind of first a little bit about thinking about pose within the theater. Then I'm going to talk about the methodology that we've been using, and then the specific platform that we've built in order to start thinking through these questions and issues. And I'll present some of our very early research findings and analysis, and then I'm going to talk a little bit about the implications of that for the future. Okay, so talking about pose and staging. Pose lies at the intersection of authorial intent, directorial intent, or directorial vision, and is shaped by the choices that the scenic designers make, and then all of that is mediated by the body of the actor. So examining pose and staging really sits at the heart of artistic expression within the theater. And it is so common and so fundamental to making a performance that oftentimes theater scholars just breeze right past it. They're interested instead about talking about the lighting choices or the design choices or all the other things, and then the staging is yeah, of course they move the actors' bodies around on stage. It's an assumption. And I wanted to approach using these computer vision algorithms to address a fundamental question. Could I quantify and analyze the physical arrangements and movements of the actors on stage to reveal something meaningful about a director's creative process? So that was the problem that I defined for myself. And to answer that question, I started looking at archival footage. So videotapes, DVDs, whatever I could find of recordings of performances. And running pose detection algorithms on these archival videos, which would then generate hundreds of thousands of specific poses. So for each frame of video, I would have the algorithm look at that particular image, detect whether or not there are people within that image, and then find the exact pose that they were in order to draw meaningful conclusions. So we started with a bunch of images that look like this, and then through the algorithm, it would kind of draw out these particular skeletons, these data points of exactly where their bodies were positioned. And, you know, at first we started looking at, okay, are there questions of, are there specific indelible moments to a staging, right? Like, and you can kind of talk about these things, or theater scholars do talk about these things, that there are certain moments of staging that stick in people's heads. You think of like Brecht's like scream moment in Mother Courage, or in musical theater, these iconic poses that people make at the end of musical numbers. And sure, we could start to analyze those. But I was interested in the aggregate effect of all the poses throughout the production, to sort of take what is called a big data approach to analyzing each specific pose, and to do it ambitiously, to do it across multiple productions by the same director, or to look at different interpretations of the same piece by different directors, and to ask, again, are there specific common poses that people make? Oftentimes when people, the stereotypes of Hamlet productions, that Hamlet should hold the skull in a certain way, right? Like, as you start to think about it, these images start to pop up, but I was trying to look at more than that. And you know, the other thing that I was struggling with was also this idea that, oh, well, couldn't a theater scholar do this anyway? You know, theater scholars certainly will watch multiple productions of the same thing, or watch or follow the work of one director again and again, and write a beautiful article about, well, here's my analysis of this is what kind of work that Bob Wilson does. You know, or this is the consistent staging choices of Ivo van Hove. All of those are possible. But I was interested in, is there a specific numerical quantification that you can do using a data-driven approach to this? So I was hoping that using data in this way, I might be able to find patterns across productions that might reveal deeper truths. So here's how we kind of went about it. This is the methodology section. So one of the first things that we really struggled with was that all of the productions that we had were captured using standard 2D optical cameras, right? That the data set that we had to work with was archival productions, some filmed 10, 20, 30, 40 years ago with regular cameras without any 3D specific depth data, or using motion captured dots or inputs like that. And so the first challenge that we faced was, can we do this with usual cameras? Because if we could do that, then that would open up the entire history of theater on film for analysis. And it was really difficult at the beginning. Using OpenPIFPath, which is where we started, is an open source pose detection software. And we kind of worked on that. That it uses convolutional neural networks, and that got us a certain amount of distance, but you can see in the difference between these things that on the right side, that's where we started, where it would kind of oftentimes not quite get very good data, or not quite be useful for us. And they really had a tough time estimating 3D coordinates, estimating like bodies in space. And so we almost just sort of waited for a certain amount of time until the algorithms got better. And this parachute kind of came in very handy in 2022 when I attended the Human-Centered AI Spring Conference, and a team from UC Berkeley gave a talk about this new system that they were coming up with called FALP. It's a system, the acronym is Predicting Human Appearance, Location, and Pose, and it is able to extract 3D coordinates from 2D film. And it is pretty much the state-of-the-art accuracy in terms of pose estimating. It interweaves the tasks of estimating human forms while also noting their appearance, that is, extracting texture maps of their clothing even, and then tracking their trajectories over time in an estimated 3D space. And a lot of this, the effectiveness is derived from the transformer model, which emerged in 2017, and I'm sure many of us are familiar with the transformer model in terms of its contributions to large language models. But vision transformers apply the same techniques to images. That happened in 2021, where you can see here they work by breaking up an image into long strings of 16 by 16 pixel patches, which they essentially treat as words, and then pass them through multi-layer perceptrons in order to kind of generate what we use as basically a grammar of an image. So here's a couple other illustrations of the way that FALP works, not just in terms of vision transformers, but also of the kind of a temporally aware transformer that tracks pose over time, while also modeling the pose joints and surfaces. And more interestingly, it tracks where the camera is in the 3D environment. And the 3D pose tracking of FALP gave us much, much better data. And then we also augmented this later on with a customized action recognition tool that was also built by the Berkeley team named LART. For some reason, over in Berkeley, they're very into one-syllable acronyms for things. The Lagrangian bit in that title refers to taking the approach of other tools and only describing about what's happening in the entire scene. So LART considers each pose tracklet separately, producing distinct action descriptions. And they have this kind of weird atomic visual actions for each person in the shot. So they'll kind of label each motion with these strange little verbs of walking, standing, clapping, which we thought would be kind of useful, but ultimately for a theatrical purpose feels kind of strange because, you know, the entire production of Hamlet is not actually about walking. There's a little bit more to it there. And then the final tool that we used is a tool that came not from Berkeley, but from Google and Caltech. And this is a trained model that projects 2D coordinates of pose into a probabilistic embedding space, which actually has like 16 dimensions. And this situates pose closer to their kind of actual 3D representations. And you know, I'll kind of show what this looks like on the platform in a little bit, but that's kind of the system. So in order to put all of this together in a way that would actually be useful for a researcher, we built a platform to kind of do this kind of analysis. And this platform was kind of built by the developer team to kind of figure out what are the pipelines for processing and running inference on videos of theatrical performances. And it's also a place where we can try out different methodologies and approaches, because the way that AI models keep changing and updating, we felt like, whatever we build has to have swappable parts so that when the next model is released, we can kind of plug that in and continue to perform these analyses. So this is a diagram of roughly how it exists right now. And it is loosely coupled. So it's what allows us to easily swap in and out these different parts. You know, the hub of the platform is the vector database, where the results of a very lengthy and extensive inference and computational tasks are stored for retrieval and analysis. So none of the results that I'm going to show you in a second are done in real time. It actually takes us about a day and a half to analyze an entire 2-hour production. And all of that data is then crunched, stored in the database, and then the platform kind of pulls out the useful bits of data and displays it to us when we need it. Then we also then built, you know, a kind of application and inference server on top of that, which allows us to change out the way that these visuals are displayed. And then it also runs a Jupyter Notebook server that allows us to continually both run different sets of experiments, and if we need to change the code, then easily it will also kind of update that up. This is all behind a reverse proxy, and the whole thing is orchestrated with Docker, which makes it easy for us to kind of deploy across different infrastructure platforms when we need it, and everything is kept nicely and cleanly in a container. So the couple times where we've had to move up to a different server as our data gets bigger and bigger, it's been relatively easy for us to do that. So, oh, that should happen back at the beginning. Hold on. I'm going to kind of show you a video of the MIME platform working. And it might be easier to look at those monitors as opposed to this one for this. So what it's doing right now is we have a series of productions all within the database. This is a production of Julius Caesar that I directed at Stanford in 2023. And this is a timeline of the production. So on the very left edge of the screen, that's the beginning of the production, and at the very end, that's the end of the production. So that's just the production in terms of time. And then we have different ways in which we can kind of look at that production. So track count, that's the number of people on stage. It tracks how many bodies it's noticing on stage. If you notice at the very end, there's a lot of bodies on stage, and I was very confused by that. And then I realized, oh, in every single production, there's a curtain call. And so that's when all the bodies come on stage and all of the statistics spike up at the end, which confused me at first, but I was like, oh, okay, now I understand that this thing is actually working the way that it should. We also track the shots, since oftentimes archival productions have multiple cameras and tracks across different shots. And then we also have some statistics about how statistically common the sets of poses are. So are people doing very unusual poses versus just standing there like this or like this? And that kind of allows us to see roughly where and when people are making interesting choices within a production. But so that's the kind of rough timeline view. And what you can do is pick out a single moment from one of these productions, and then for each individual frame, you can see it down below where, okay, here's the moment in the show, and you will see the pose detection overlays on every single character in the show. So all of both the number of people that are on stage as well as the precise pose that we're in. And then you can say, oh, I'm interested in this person's pose, and click on that, and then it will show you every other pose that is made like that throughout the entire production. And we built a little 3D model doll of okay, here's the pose in 3D. And also that because there's not a good language for searching for pose, you can reposition that doll and it will find those other poses within the corpus of the data. So this is all of the other poses that you can see and find other moments within the show then that happens. And so it'll both give you the visuals of that and then see these brown lines on the timeline, those are the other moments where those occur. So it allows you to kind of map out, here are the other times where people make these poses. And then you can start to see certain themes and analyses or ways in which the director consistently has someone do a particular motion again and again and again. And you can start to see how meaning is constructed by a director by seeing where and when and how often certain poses recur within a show. So that's the very like one of the early kind of features that we built into this system. The next thing that's going to happen is, then you can also search for similar actions within the show. So beyond just the particular frame of video that's consistent, we also have this idea of action, which is a slightly longer, multiple seconds of action, because again, at least in English, we didn't have a language to really describe pose beyond just a single image, but to also recognize that gestures happen over time. Oh, and then here's the important cool part, that you can also extrapolate that data and put it into 3D space. So that's the exact same pose, that's all of the pose on stage, but then placed into 3D. That again is just the same data points, but allows you to break the kind of tyranny of one single camera angle, right? If you're looking at archival footage, you only get it from one particular angle. But we realized, if we have all of this 3D data, we could also show it to people in 3D, and that would allow you to zoom in and zoom out on certain moments of staging. These are the results of the face tracking, so you can see, because actors oftentimes play same roles or different roles, you can see where and when actors are on stage or off stage. Like you'll notice that track 1, Julius Caesar, he's only on stage until he dies, and then his track disappears. So this was like another way in which we started to kind of think about correlating pose to specific bodies and pose to certain people. And then this is our kind of clustering of pose. So looking at this in terms of the totality of poses, you can start to break it down to what are the sets of common themes or clusters of pose that reoccur often. And because apparently I'm not an interesting director, the most common pose for me are people just standing straight there, which was a little humbling to realize that perhaps my work is not as thrilling, choreographed-wise as other people. So this is like another kind of like visual representation. Oh, and then you can kind of like scrub through different sets and clusters of poses to see where and when those also occur. The other thing that we did is this is every single pose in the entire show. Usually a data set from one particular production contains over 1 million poses. And so we tried to kind of visualize this for an audience so they can kind of see where and how in 3-dimensional space all of the poses in a particular production are. And then you can zoom into bits of it where you'll be like, aha, well, here's the exact pose of how one actor for one scene sits, and they all happen to sit together. And then you'll notice that, in a different scene, she sits again, but her back is slightly up. And so you'll find these interesting, weird little clusters. And that kind of gave us a sense of actually how freakily accurate this thing is, that it notices the difference between someone sitting in a chair here versus someone sitting in a chair here. And you'll start to notice these kind of interesting commonalities throughout. The other thing, and I think this video is about to do it, is that you can then take all of these poses and order them again on a timeline. So these are now all of the poses ordered visually. So again, you start to notice here's sections where there's a lot of people on stage versus monologues where there's very few numbers of poses on stage. And then you can also sort by the different clusters of, again, where within the particular production from the beginning to the end do certain clusters of pose happen. And then what we're doing right now is working on a new set of interface because we were really struggling with this idea of searching and finding search spaces for pose, because that's hard to articulate in language. We've been trying to figure out ways in which we can find these kinds of different poses. So this is the next version of it that is still super broken, or we're still kind of working it out, but it allows for a much better way to visualize and see certain common poses within the thing, within the corpus, as well as to compare poses across multiple productions. So we take one pose from my production of Julius Caesar, here's some productions of Pina Bausch, and you can see where those poses show up within her work as well. And the idea being that this could be useful to scholars as well. And then this is one of my favorite features. We were lacking language, so we built a take a snapshot of yourself. So it will do that same kind of pose detection on an image of yourself, and then find that specific pose within the database. And that allowed us to move past language and just search in the grammar of pose ourselves in order to find these kinds of specific poses without having to articulate or like move a doll to the precise positions that we wanted to find. And again, this is a cross corpus search system. So, oh, and then the last thing is, this is the Jupyter Notebook running that is there behind all of the work that we're doing, so that if we wanted to update something instantaneously or kind of find a different set of like search processes, the Jupyter Notebook is right there, and that it allows us to kind of very quickly update to these things or generate specific sets of data as we are working through this. Okay, I think, yeah, that's the video. So I'm going to talk a little bit more about some of our initial findings and the things that I'm particularly interested in. This is still the most bleeding edge results that we have so far. The thing, weird, that I'm most interested in right now is looking at the differences between different directors. And so after we ran a whole lot of analysis on these, we kind of looked at this whole total data sets, and from the pose, from the action, from the motion, and the distance data, we asked ourselves, what was the most effective at predicting a stage director's work? And so these are called leave one out tests, where we assembled the average pose distance and motion features, and then looked at it through a bunch of different ways as aggregates across all of the different vector averages. And we started to find that, so we chose 3 directors, Bill T. Jones, Romeo Castellucci, and Krzysztof Orlikowski, 3 very different stage directors, but we were able to find 10 productions on video that we could then analyze, and ran them through these systems, and then again ran them through again, and the data sets that we started to return back found that there were consistencies amongst each director that showed up, and that the features using 3D pose coordinates and action recognitions did a little bit better for telling different directors apart. And this is still pretty messy, but within each of these sets of data sets, we were able to kind of differentiate the directors based off their motion and distance statistics. And these sets of features, pose, motion, and distance, and view invariant pose distance means just that, like, based off of where, no matter which way the camera angle is placed, the the pose is still consistent across that. So view and variate tended to be a little bit more interesting and precise. And yes, there are some very large error bars within that. But it does seem that the average amount of motion in a video is one of the more powerful predictors of a director's identity, whereas the average distance between the actors is not so much useful. So a way to say this in less technical academic language would be that the amount of movement that a director puts on stage is one of the leading indicators for a specific directorial style. And then what we tried to do, and sorry, this posed, this is a very hard to read chart. But we started, again, kind of querying the data, and this is, again, extremely noisy data, but we started to query the data in terms of what, in terms of pose, tends to distinguish certain directors, and these are across 10 different productions, so that means the actors are different, that means the text is different, that means the lighting and design choices are different, but they're still able to say, this is clearly Bill T. Jones, or this is clearly Warlikowski, or clearly Castellucci, based off of, again, it's a little bit hard to read, but the right wrist tends to be a way in which they'll start to notice those differences. That's the consistent feature that this thing would detect that, again, because the data is so noisy, it's hard for us to understand that, but it would kind of sort through that. So maybe this is a little esoteric sounding, and I apologize for the confusion if it is, but if it helps, this is a representation of all of the poses, of all of the shows, so that's 30 productions, organized just by pose. And again, take a look at that monitor, because I think the colors might be a little bit more indicative of what it is. You can see that Warlikowski is blue, Bill T. Jones is red, and Castellucci is green. And while you can see there's a definite overlap between Warlikowski and Castellucci, the redness of Bill T. Jones kind of sticks out. And this is a three-dimensional model, so if I had chosen a different picture, I could rotate it for you, and you'd be able to see it in different sets of projections. And so, again, while it's extremely noisy, you can start to notice that there are distinct clusters of poses that seem to be consistently of a certain directorial style. Okay. The last thing that we've been working on is comparing the same bit of staging from multiple productions. So we kind of started looking at opera, since that seemed to have a little bit better of a corpus for us to work with. So this is from Don Giovanni. And what we've been looking at is the finale of Act 1 from these, 7, 8 different directors. And so again, we kind of put them through the same kind of pose detection and analysis, and what we had to do is align them, because it's, and this was actually helpful that it was opera, because it's music, we had to kind of align them in terms of time. Certain conductors would take certain pieces faster or slower, so we had to shrink and kind of, or expand other pieces, all of the scenes, in order to find those consistent moments within each production. So we had to do some time warping here in order to get them all. And we also had to make an interpretive choice of like what should be the standard. And so we chose a particularly boring production and said, well, this is the least innovative, least like Regietheater production, and so let's say this is the standard, and then let's look at poses as deviations from that. So this is it all aligned, and then once we were able to align it, we were able to kind of get a pose consensus for things. This way we could calculate average poses and actions, based off of, in relationship to what other people have called like a consensus performance, or the tradition dominant cultural expressive form, and then from that calculate to the degree from which each director's staging deviates from that consensus at each particular moment in the scene. This particular, this is a plot of where and when different directors deviated from certain moments from the consensus staging. And this is, still a work in progress, and honestly, these results are from 3 days ago, so we're still puzzling it over. But I'm interested because this is a way in which we can start to say which sets of stagings are unique to the consensus versus which sets of stagings fall into certain patterns that are culturally determined or fit within the sets of norms that we're used to thinking about when we think about the Act 1 finale of Don Giovanni. And, not that this is like the end-all and be-all for human creativity, but I think it's an interesting way that we can start to think about mapping sets of creative works. So stay tuned for the results of this. All right. The final thing that I wanted to kind of talk about is the implications of all of this. Oh my goodness. I'll speak much faster. Here's the kind of like implications of this research that I think are interesting. So number one, I hope this opens up new avenues for looking at the work that a director does. This is particularly significant because while certainly the creative contributions of a director are celebrated and important, it's hard actually to quantify precisely what a director does. And hard oftentimes, as many people will say at the bar after a show, the actors did all the work in this show and the director barely came to rehearsals, or, they were saved by the designers at the last minute, So I'm interested in ways in which we can actually start to quantify the creative contributions of a director. And oftentimes, the creative contributions of a director are just sort of minimized down to, they made this one particular beautiful moment, or this one tableau that sticks in your mind. When in reality, staging a theatrical production is a meticulous process that happens over weeks, and a director is responsible for every single moment, not just the one particular pretty thing that they take the production photos of. And by using this technology to examine this work in minute detail, we can gain a more comprehensive view of that artistic position. And I hope that this kind of technology opens up new ways of thinking about and examining a performance. By using pose similarity, we can start to identify recurring poses, symmetry within poses, looking at the overall timeline view to see the rhythm of a production. You can start to see where certain moments within a production recur consistently. You can also use pose to identify common themes and stylistic elements of a director. And that's a way that you can divorce their work, the director's work, from the work of the performers or the constraints of a particular space or text. And by analyzing pose and movement across an entire body of work, you can see the evolution of their style from maybe early works of a director to late works of a director. And those are often elusive when you examine a performance just one time at one particular place. And then also, as I kind of mentioned before, we're starting to think about different directors' interpretations of the same material and hopefully revealing new dimensions of artistic expression and decision-making. And this technology, I think, also has implications beyond just theater, right? There's ways in which you could use this technology for analysis of political speeches or any types of public performance. I think there's also ways in which you could use this platform for the analysis of athletic performances or sports or any of other times where people are putting their body into specific motion. Oh, and then the other thing I keep thinking about too is you could, if you had enough rehearsal footage, use this to track the development from an initial staging to the final staging of a piece. And ultimately, I think there is an archival value to this kind of work that, film stock and video works can decay over time, but if you are able to extract specific pose data from a particular performance, if you are interested in restaging or analyzing a performance when the video is particularly grainy or bad, putting it into 3D and seeing those precise poses could allow for different scholarly interpretations or saving this kind of choreography of a director in particular. So those are all my hopeful, optimistic, California, dreamy potentials for this kind of technology. And because it's a talk involving AI, I also have to talk about the other sides of this. So, the ethical considerations around doing this kind of work are huge. There's copyright questions, there's questions over acceptable use, over people's choreography and stagings and body positions, and that's one whole gigantic area that at Stanford, we don't release any of these videos publicly. These are all performances that are documented within the Stanford library system, so we're keeping all of that data secure. At the same time, too, while our algorithms have improved a lot, they're also prone to hallucinations. And so that's been another deep concern that the team and I have had about how precise are we getting versus how often are these machines just hallucinating the particular poses or believing that sometimes a chair is a leg or something like that. And so it is a very complex ethical landscape that requires very careful navigation. And as a team, we have developed clear guidelines and frameworks to ensure the responsible and ethical use of these technologies. A thing that maybe I'll talk about is where these algorithms came from a Berkeley lab, as I mentioned, but largely the sponsors of these works are self-driving car companies and, more terrifyingly, the Department of Defense in terms of looking at and analyzing specific poses off images that could come from satellites or drones or other sets of military intelligence. So I think there's a lot of concerns and dangers in addition to working with this. And then finally, because I think this is also a question I get asked after I talk about this work, from an analytical point, I also think that it is important to recognize the limitations of focusing solely on pose and action. As I think many of you all know, theater is a multifaceted art form. And while pose is one component of it, and an important one, it is just one thread of a very rich tapestry that includes dialogue, that includes set design and lighting and sound and so much more. And if you don't take in those other elements to account in terms of a performance, you really run the risk of not interpreting a production properly. And so as much as I'm excited about the insights that a computationally analytic approach can take, this should all be viewed as a complement to the work of a scholar rather than a replacement for traditional methods of artistic analysis. So the way that I talk about it, it is a very narrow but powerful lens through which you can view a performance that enriches our understanding rather than supplanting it entirely. And then finally, and I hope this is obvious too, but this computational approach cannot determine directorial intent. These patterns that it notices may stem from conscious directorial choice, actor improvisations, or even unintentional recurring elements. And so, as such, these patterns are the starting point for a much deeper, nuanced investigation rather than the definitive conclusion or endpoint. And so, again, people get very worried when you start talking about AI, about the ways in which it could replace human beings. And I hope that it is clear that I view this tool as a way to enhance and supplant the knowledge that a theatrical scholar should have, as opposed to replacing the work. Because honestly, without a scholar to interpret this kind of data, it is pretty much useless. It doesn't offer that many insights unless you have a human being who has experienced that same production interpreting that data. So all of that is to say that it is my hope that we can develop a more comprehensive understanding of theatrical performance and directorial style in a way that ultimately enriches both academic discourse and practice. Thank you all so much. This is where we chat?
Yes. Wow. Yeah, thank you for your lecture.
Sure.
It was very interesting, I think. Are there questions at first? Yeah, Philip? Bring it back to me.
Thank you so much for the talk. I was wondering, it's a very unique way to look at performances and theater plays, especially through the lens of a machine that is cataloging all those different poses. Did you have any surprising insights? Like, are people standing more still than you anticipated? Do directors have like signature poses that are repeating or something in that direction?
Yeah, often there are certain particular poses that certain directors use. I think the most surprising and humbling moment was when I compared the pose, like the interestingness, like how often the work that I've made, because I put, of course, my videos into the system, I compared that to the interestingness of Pina Bausch, and humblingly, I am not as interesting of a director as Pina Bausch. So it was an interesting insight in that, like, I kind of knew that, but it was, once you have it mathematically presented to you in that way, it is very humbling. And then the other thing that was interesting is that I've been working on this analysis for maybe like a year now, and in the middle of doing this work, I staged a production. And I found myself in rehearsal being like, oh no, I need to make them like do these weird things so that if I look at this later, I'm not gonna get such a bad score again. So in a weird way, it kind of prompted me to be a little bit more creative, is maybe the nicest or most hopeful and surprising result that I found from how it started to influence my work.
Thanks.
Sure.
I have a microphone. You can. Is there any other questions?
Yes, thank you so much for your talk. It's very impressive, the tool you made. One thing that stood out for me was like the thing that you are cataloging or indexing all these data of the poses, and I would very much like to see these 3D reconstructed scenes of the stage and the place. And I was wondering if you are thinking about reconstructing these 3D scenes in maybe in a 3D environment, like for virtual reality or stuff, because it points to the thing you said about the archival topic of this tool.
Yeah.
So I was imagining like you could reconstruct the scene and have a copy or like an archive copy of it for conservation.
Yeah.
And even further, we could think about doing a robotic play with the 3D data of the poses. And stuff.
Exactly. That's one of the things that I think right now we're still, like I've said, we're still in the very early days of this work. Right now we're just generating pose data and trying to look at it as a whole. We've talked about, yes, it would be very easy to export all of this pose data and put it into Blender or Unreal, and you could rewatch a show, but animated by like a robot or a space alien, like doing Pina Bausch choreography. At the same time, I think that's where my strict sense of AI ethics also kicked in terms of, I think that also might be unfair to the creators of those works who made that. And so until I have explicit permission of like, please, Michael, go and do this and take the pose data and put it into a different program to export it, I've been avoiding that. So that's been like one thing that like, I thought, interesting creativity, possibility there. The other is certainly now that we have a bunch of like millions and millions of 3D pose data, it would be easy to train a model to generate new kinds of poses, right? So that I could, and again, my ethics are like, maybe I shouldn't keep this Pandora's box closed, but I could say, there's 7 productions that I've directed in the data set, say, build an AI that generates new Michael Rau stagings, or here's a system that then generates new Pina Bausch choreographies. So it is possible, but I worry a little bit about the implications for that and the copyright rules, and then emotionally, as an artist, artistically, I also think that that's actually like staging as a director is one of the joys of art making. And the last thing that I want to do as I'm working with machine learning algorithms is take away a joy from another human being in terms of creating art. And that's really important to me. And so I'm a little resistant to that, or I want to think really clearly and deeply about that kind of implication before I do something like that. But excellent question.
Thank you. Thank you.
Yeah.
Yeah.
I have a question about the 2 things. First is what will be the next steps? So you have all this kind of data.
Yeah.
Will you make some kind of maybe chain of movement, some analysis? And the next one would be how do you analyze this in terms of meaning or reason? So it has some kind of, so you get something back from it just from looking at it. It's nice to have these kind of poses, interesting, and this all these poses together. But what do we learn from this in that moment?
Yeah, this is an excellent question, and this is like what I'm struggling with right now, because the data sets are huge, and when you start looking at millions of poses, it is possible to start to make an argument for nearly anything. And so that's the thing that I'm trying to figure out, is like what is actually meaningful about this data. And I think that's the part that I'm still looking for. Like, I can certainly look at a production and say, aha, yes, they do this pose 27 times, but so what, and that's where I think, it's just been like, again, we're just getting this research data back. I'm going to sit down with a particular production and try to say what is actually meaningful within this unique data. I've certainly, in looking at my own work, that production of Julius Caesar, I noticed that the actors did sets of poses that I am pretty sure, because I was there for all of the rehearsals, I never asked them to do. And like that was interesting. I noticed that there are certain moments where actors will copy certain gestures from another actor, but again, that can just be a normal kind of thing. But I have yet to kind of find, this is the like big overriding, deeply interesting, profound thing that I can say about a production just using pose. But if you have an idea, please, I'm super interested.
Well, maybe as a follow-up to the question, I was wondering, you talked about the meaning in the data. Do you have any plans of connecting the meaning of the poses to what is actually portrayed in the scene? Because the same pose could mean like wildly different things, I guess, in different contexts.
Yes.
So is there any idea how you could connect that? It's a little follow-up to the question before, because that would be, personally, I think, interesting.
Yeah, I think that, I mean, I think what it's going to take is probably, because I'm very art focused, and then there's also like a lot of technical stuff. Like what I really want to do is partner with a theater scholar, like someone who's really dedicated to analyzing a production, and sit down with them and say like, okay, I can show you this data here and this data here. What do you think about that? What do you think all of this means in terms of production? Because I think that's the thing that I'm really, I don't know, maybe I'm like a little too either technically minded or like artistically minded to kind of do that deep analytical research that, you know, many other scholars seem to be able to like look at data and be like, this means this. And I haven't quite figured out what that means, or that like this certain gesture implies blah, 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 blah. So if you know any theater scholars who might be interested in this work, please send them my way as well.
Yeah, I often ask myself why Apple produces so good TV shows, and if they use tools like this, analyzing tools like this, to how they construct the stories. It's not, it's the reason why, I think. My question is, do you have ever involved this analysis technique into a development for a stage play? I think you can construct in speculation room, and you have a camera, and you make the development, or you develop the show or the choreographies, and you filmed it, and then you you have the information about the poses and what the actors are doing. And then you can say, put me the data set of this artist or this artist into it, and what will he do in this situation or in this process?
Yeah.
That you have a lot other patterns for the evolution or the develop of your stage play.
Yeah, I mean, I think that is definitely a possibility of all of this, that it would be possible and perhaps interesting in the future to kind of say, to analyze if there's enough data within this system to say, okay, here's one particular set of poses and staging that I've made, compare it to the way that Romeo Castellucci might stage this, and then you might get, it could be as a creative tool to kind of spark different sets of inspiration. Is that what? Yeah. It's, you know, it's the same kind of technique as, you know, those AI filters where you can say like, okay, here's a picture of my face, but now do it as an impressionist. You know, you could kind of, here's a set of pose data, now do it again as a particular artistic style. And I think that's going to start happening further and further into the future as this technology and these algorithms become faster and easier and more implementable in the future.
Yeah, to involve these processes in the development, yes. Yeah, another question is, the headline of our talk today is on the internet site is how to produce with AI or with artificial intelligence, intelligent art.
Yeah.
Or intelligent art, yeah. What would you say? How you have yesterday talked about it, and I like your point which you make. Perhaps you can remember it, or reconstruct it, and Yeah, and I think it's a good point what we can make with artificial intelligence in the art and development processes.
Yeah, I hope I'm going to remember what I said yesterday.
Yeah.
Please tell me if I don't. But I think I kind of touched on it in a couple different ways here. Like, there's a tremendous amount of anxiety these days, especially for people in the creative industries, that these machine learning algorithms are going to replace people. They're going to replace artists. They're going to replace the work that we do. And I think that fear is real, and I think we should be concerned about it. And I see a particular responsibility for myself as both an artist and an academic and a person who understands the technical aspects of programming, as well as, like, I was trained as a theater director, to find ways to implement these tools in a way that doesn't replace human creativity and human work. Certainly in AI circles, everyone talks about human in the loop, that there should always be a human as part of the AI system. And less so in the creative industries do we talk about human in the loop. And so that's what I kind of try to do, is like, what are the sets of tools that I can build that still preserves the joy, the fun, the interesting, the creative parts of it, and how can these AI tools add a different, like a slight dimension to it, but still preserving people at the center. So I can show, if it would be helpful, the video system that I developed while here at the Academy, that I think is maybe the, oh dear, hello. Okay. This system uses a live performer, that's the person in the little window, and then an AI system that generates images based off of that video feed. So it's that camera feed of the live performer goes into a computer, it uses image-to-image translation, and then generates out prompts based off of or images based off the prompt that we put into it. So in this case, it's Hamlet. And with this particular algorithm, what we were really interested in doing is making sure that the human body is still at the center of the creative process, and the machine learning algorithms would just add a secondary layer on top of it. But without that human being within there, or that person who's kind of creating those images, the algorithm isn't necessarily doing as much interesting work, except for when, as you can see, what he was trying to do, which is like promote hallucinations in the machine learning algorithm at that moment, by kind of covering up the screen or hiding the human being within it. So this is one of a couple other different AI tools that I'm building that are kind of designed specifically for creative applications. Yeah, so I'll stop that if it will certainly be distracting. Oop. Okay, that's a nice one to pause on.
Yeah. Yesterday you talked about your turning point.
A what?
Your turning point in your evolution
yeah.
is that you are changing in 2011 from 11, sorry, from a theater director to what's now? An artist, and scientist, or a technician, or what you are seeing or thinking you are about yourself.
Well, so yesterday I talked a little bit about a crisis that I had in 2011 when I was making work as a theater director, and the work that I was putting on stage did not reflect the life that I was living, where the stories that I was putting on stage were all beautiful, people falling in and out of love, having drama, dying, all of this kind of stuff, but so much of the life that I was living was mediated by digital devices, that my friends, my family, my deep, profound, beautiful aspects of my life were all happening via text message or email or all this kind of stuff. And I couldn't find a way to capture that precise feeling on stage. So I had this crisis, and then I was like, oh, I have to change the way that I make work. And that kind of sent me on a whole journey of making performances that had digital media as the central storytelling point. So I made a show that happened over email or that uses email as a tool, and that kind of sent me down all of these really different paths, and that are all about kind of capturing the intimate and profound and deep ways in which our digital communication devices change the way that we experience stories. And then I've been doing all of these experiments with AI, but I'm stuck right now because as much as I think people are talking about AI all the time, it hasn't totally penetrated our lives to the point where we like forget about it, where it's not meaningful to us. Instead, we all have these fears and worries. So I'm making a production that is a reference to Hamlet right now, but is mostly about those sets of anxieties and fears that we have about what should we do with this AI, which parallels to Hamlet's confusion and indecision about what should I do with my life, as well, now that my father's dead, et cetera, these kinds of questions. So I think there's that. In terms of answering your question of like, who am I now? What a profound question. I still view myself firmly as an artist, and really as a director. As much as I go to faculty meetings and spend hours looking at computer code, I think the way that I think about my responsibilities, the projects that I want to do, the things that I want to make are all theatrical projects at their core, and that's kind of still my self-conception. Yeah.
But it's a synthesis from a technical way. You are thinking from a technical point out, and then you have a look on the audiences or the visitors or the spectator, whatever, and then you grew up in the artistic mindset, or and you use it. You use the technique to involve or to make an immersive experience for the audiences. It's immersion a little bit. Tamping, as a sort. Tamping is an immersive stage play for me.
Totally. But at the same time, I also view the role of a theater director has always been a certain amount of a technician, or there's like a lot of technical knowledge. It's just usually as a theater director, you get trained in the technical knowledge of how lighting works, how sound works, how stagecraft works in these ways. And I just think that what I'm doing now is just adding a little bit more bits of technical knowledge to this art form that I really love. And kind of what I love about theater is that it's always been an art form that embraces the ways in which technology changes, sometimes fast, sometimes slow. But if you look at from when theaters move from outdoor to indoor, from gas lights to electric lights, it is an art form that brings in technology and then changes the art form in some kind of way. And I kind of see the work that I'm doing as, this is not as grandiose as it sounds, but like trying to prepare this art form for the ways in which different sets of digital technologies can change the form of it.
Yeah, and if every director is in the future is an effect, you could say I will see this film in the style of Kubrick or in the style of Michael Rau or somebody else. I think it's interesting. Any other questions? Yeah.
In the future, would you replace the operator in your cubicle play with an AI?
So we've talked a lot about it, and beautiful thing about that particular installation piece, for those of you who weren't at the talk yesterday, I talked about this installation piece. It's for one audience member. The entire show happens via email and voicemail, and you just do office work in a cubicle. The reason why I don't think we'll ever replace the human operator is that human beings are so weird, and they continue to do such unexpected, weird activities that even we built that show in 2014. It's been running for 10 years. It's the most solidly over-rehearsed piece that I've ever made. I'm so bored of it. And at the same time, every time we have a new audience member in the show, they will end up doing something slightly different or slightly strange or sometimes totally surprising, that I think will change, that always requires the operator to do something totally different than they haven't planned for. Yeah. We experimented it once. I built a little email responding bot that could do that work, and the results just weren't satisfying. So,
even if you would train the AI with your actions you did previously, I think you have everything on video.
we don't have. There is like a camera feed, but we don't save any of that video. And it's more about what. There's a bunch of stuff that's happening during that show where I don't think people will write things sarcastically that like a large language model just doesn't necessarily like understand. And there's 20 different characters that the operator is in charge of in that show, and those characters need to have custom responses and again respond to the specifics of what the audience member is asking. And many of those are pre-written, but not enough of them are pre-written in order to like keep the audience completely on track. But who knows? Like 5 years from now, I'm sure this technology is going to get better and better, and I might be like, well, it's all automated now.
Yeah, I have a technical question.
Oh boy.
I was thinking about the algorithms who are representing, in the end, the poses or the gestures and postures. What do you know about, like, is there a smoothing effect in these algorithms? Because I was wondering if we would watch the skeletal views only, and if we would enjoy the piece or the play, or would we even could we even understand which piece it is?
Yeah.
By looking at the skeletal view of it.
Yeah, that is. So I have tried that, and it is very hard to understand. You don't until you actually look at it. Only using those like pose skeletons, you don't realize how much information is presented to you visually. And really, I think that like those pose skeletons are more useful for algorithms to learn from that data as opposed to human beings to see it. I constantly, when I'm trying to do these analysis, toggle off the pose skeletons. And if you kind of watch a whole scene in 3D, there's so much data. You realize all of a sudden, like, there's so much information that you're missing in terms of eye line, in terms of facial expressions, in terms of other things that are really crucial to human beings' understanding. There's probably, I don't know, it feels like watching a puppet show is like a good way to describe it, but a terrible puppet show, like as performed by awful puppeteers. It's also that we had to simplify our data. Like the FALF algorithm can return 72 points of skeletal information, and we already were dealing with millions of poses, and if we added any more data points to the skeletons, it became so complex and so that we were like, we'll never be able to kind of quantify this into a useful thing. So we actually simplified all the pose skeletons down to 16 points, which is comparable. Microsoft did some of the early research on these kinds of like pose detection systems, and they've always kind of done a 16-point cloud system for understanding the specific pose, and that also allowed us to use a different set of libraries that we could then put that into 3D space, this kind of stuff. But the FALP algorithm can do very specific hand tracking, very specific eye tracking, and if Stanford is going to give us more supercomputer time, maybe we would like upscale to that data some more. But for this still early investigation into this kind of data, we're taking it easy.
Yeah, what I think when you bring the example of Pina Bausch, I thought there are no partitures, there are no, not a notation system how you can write down what the dancer is doing.
Mm-hmm.
And I thought if you have these videos, you can make an analysis and then you can put it on a virtual representation and put it on an HMD, and then you can see the virtual representation of your body, and you must try to dive into these movements, and so you can train yourself, or you can teach, or you can learn how you can dance as Pina Bausch or something else or somebody else. And I thought, yeah, it's a good method to make a transfer of body movements to another person or to train people. How do you how you integrate your development in the teaching on the Stanford University? What are the courses and the lectures there?
With this particular research, or just in general?
Well, in general.
Because with this particular research, I've just been like doing this as a side project, and my students aren't involved in it. You know, in general, the students that I have at Stanford are very interested in the artistic side of things and less in the technical side. And it has a lot to do with like the particular pressures that Stanford students feel that if they go to the computer science world, then they're very focused on like, okay, I'm going to build my startup. I want to make the next Google. It's you know, like these are the kinds of things that they're focused on. And then they come to the theater department for like relief, where they just want to think about art for a little while. And every time that I'm like, hey, do you also want to talk about pose detection? They're like, oh God, no, like leave me alone. I just want to like think about something else other than that. And so I've kind of learned to really, because I think one of the best things that I do with my job at Stanford is convince people that their responsibilities don't have to be solely about programming and trying to earn more money, but that there's other ways of using the kinds of knowledges that they have for artistic ends, for analytical ends, for the service to humanity as opposed to service to capitalism, you know. And that's really the ways in which I try to incorporate my research, is to show them there's possibilities for using computational methods that don't have a $ attached to it at the end, but instead have a satisfying artistic, aesthetic goal attached to it.
Okay. And your students, they come from the technical side of the university too, or they're only artists? Or?
They're both. You know, the number one major at Stanford is computer science. So it is like, I think it's some horrifying number of like 75% of them major in computer science, and then 25% of them do something else. You know, English, economics, psychology, and then like a very small number are theater. And yeah. And then half of the computer science students will choose an additional major. So it's like, they'll be like, yes, I'm a computer scientist and I also do theater. I'm a computer scientist and I'm a psychologist, or that's really the kind of dominant mode that the students operate in.
Cool. Okay, any other questions? Okay, I have no more questions. Niklas? Ah, no, it's for the camera. Okay. Okay. Yeah.
I've got not a question, but more like a comment maybe.
Yeah.
Because you were asking about support with the hard challenges of the qualitative meaning of poses and gestures. And as I'm a sociologist, we deal with all these hard problems called non-verbal communication, for example. And there are in ethnography, psychology, and sociology, we have like this. We're trying to do this notation style transcripts of, for example, videography and stuff like this, where people are talking with each other in a therapy or stuff like this. And of course, they are gesturing with their hands and stuff like this, and always trying to understand, to interpret what is the transported meaning of like this one, or I don't know, this one. And one thing Václavic pointed out many years ago, a communication theory guy, he was saying that like the nonverbal communication is per se multidimensional, so it's quite a hard problem to find the words, as you said, for all these poses, I think. So yeah, it's still a lot to do, but I think this tool you're working on is could be a really good help for this endeavor. Yeah.
Wow. Oh, thank you. I mean, I would love to talk to more sociologists about how they might use this tool. It would, and especially if other people are struggling with the same thing that I'm struggling with, just to derive meaning solely from poses.
Definitely.
Yeah. Thank you. Yeah.
Ah, Niklas. The mic, wait for the microphone.
My question actually is like, how comparable is like your software, like to like there are like different how was it called, ControlNet, I believe, on the base of Stable Diffusion. Like, how comparable is the data you're getting out of this? Because it sounds like you're getting quite a lot of more data out of just simple points. Like you are able to get like in 3D space.
Yeah.
How is that being measured? You're using technologically just one camera, or are there like a couple of more in the room, or are you just comparing like different camera views you have? Because you said you just have one main view on the most place, right? So how is it getting this three-dimensional data out of this? Is it, and how accurate is it actually?
Terrifyingly accurate is the answer. And the way that it does that, and this is a gross simplification, because this is like where me as an artist, my computer science knowledge starts to get like a little bit, but from my understanding, what the algorithm does is at first it looks at the entire image and detects, is there a person within this image? And then as soon as it finds that person, it locates the head and the chest and the knees. And then it starts to draw lines based off of that, and then extrapolates out from that. If the knee is here, then most probably, if it can see this much, then it means the foot is here. And then it extrapolates out, and it uses not just the like gross body positions, but it also uses clothing and maps where the clothing goes. And as it figures out the math of the clothing, it also implies, if his jacket is moving here, that means his hip must be here. And if the hip is there, then that means the leg must be there. And so it is a very, very complicated prediction, or very complicated guess is what the algorithm is doing. And that's why, as much as I am like very impressed by the way that this algorithm works, it is all a prediction as opposed to an accurate mapping, because it is using camera footage that was not intended for this purpose. There's no, if you've seen like Bluetooth trackers that people will sometimes put on the bodies, that's not there. There's no motion capture suits. It's all just kind of extrapolating from a particular one image, and then it goes to the next frame of video and runs that same calculation again, and then it goes to the next frame of video, and it does this millions and millions of times, which is why it takes us a couple days to run this analysis for just like a 2-hour performance.
Yes, Elon Musk used the same technique in this Tesla car, so for the automated driving systems. But yeah, there was a problem with the horizon when it was too bright.
Yeah.
And, the car can't identify the white truck in front of the, and then it's happened an accident here. And
well, and that's why also, you know, those pose detection systems that run in cars, they're supposed to run very, very fast because cars are moving and sometimes moving very fast. The good thing about the system that we use is that it goes very slow. So the car systems, they're like, this is useless for us. But for our very slow analysis, it's much more precise, it's much more accurate, and it just takes a lot longer because it requires a lot of computationally intense work for it to calculate all of the precise vectors. If you notice that video that I was playing when you came in, you'll see that the bodies of the dancers are all outlined in a specific color. That's Valve doing its work. And you'll notice that the clothes, even though they're not connected to the body's skeleton, are also outlined because Valve detects clothes as a texture map and then kind of reverse engineers what the body's skeleton is doing based off the movement of clothes.
And is it possible to make experiments against the predictions? You know that you find movements which the algorithm cannot predict. I think it's very strange, but
yeah. There's also this, I mean, it's in the video that I show at the beginning, you can see there's moments where the dancers are touching each other, they're like picking each other up, and those are the moments that the algorithm breaks, because all of a sudden it's like, wait, what? There's like 2 people here, and how does the hand... that I also think, I mean, number one, it's common enough that we've kind of had to build that into our data set in terms of a lot of error handling and noise in our data. And at the same time, I also find those moments where like the algorithm breaks to be like weirdly beautiful. And if I was going to think about more creative applications, I'm really interested in those moments where the pose detection algorithm starts to crack and crumble and do these really, really strange things.
A new notation for choreography.
Yeah. Exactly.
Nice.
Yeah.
Okay. Any other questions, or what would you say anything more?
No, I thank you all so much for coming out. I know that this is before a big holiday weekend, and so I appreciate you all being here and listening. So thank you all so much.
Thank you for coming. It was a very good lecture, and it was a very nice time. Thank you for the 2 days.
Thank you.